Assalamualaikum and good day to all of you. This video will cover on the processing of GNSS data by using a Trimble Business Center version 5.2, which is the TBC 5.2. Okay, before we start the processing, you need to ensure that you have all the data, either from the Trimble data, Trimble raw data, or the Rhinex data. Okay, and another one is you need to ensure the coordinate system that you will use for this processing. In terms of the coordinate system, you need to know the coordinate system for the base station, because that will be the reference coordinate for our processing. Okay, so before we start, you need to open the Trimble Business Center software, TBC 5.2, and then the first step is, actually there are several steps that you need to follow in order to do the processing. It is start with the creating a project and then importing the data, and after that set the baseline quality for baseline precisions for the processing, and then perform the baseline processing, and then do the network adjustment, and finally produce a report. And in between, in a baseline processing, there are also an editing for the signals or satellite signals that maybe you need if your data or your observation data not meet a requirement. So you need to perform some editing. So in this video, it will also cover the editing part. Okay, so we start with the creating a project. So you need to click on the new project, and then select the blank template, and then click OK. Okay, we need to wait for a while until the interface change to the plan view here. Okay, so the next step is to set the coordinate system. You need to click on the project setting and click on the coordinate system, and here you can set as a change. Okay, click the change and click on the coordinate system and zone. This one is actually because I select this coordinate in a previous project, so it's appeared in the select recently used system. So for you that start the processing, you need to click on the coordinate system and zone, and then find the coordinates that is based on the base station. Okay, for example, in our project, we will use the core station that is based on the that is provided by the JUPEM. Okay, and for the core station, the coordinate system is in a GDM 2006. So it means in our processing, you need to set our system or our coordinate system followed the base station coordinate system, which is based on the GDM 2000. So if you look here, there are two coordinate system that is based on the datum GDM 2000, which is the Malaysia Cassini geocentric and Malaysia RSO geocentric. Geocentric here means that it based on the datum GDM 2000. While another coordinate such as Malaysia RSO, Malaysia Cassini, and Malaysian RSO here, it's based on the old datum, which is MRT. So in this processing, I will select the Malaysia Cassini geocentric, and since this is the Cassini coordinate, so you need to select which zone that is related to your data, and because our observation is at Perlis, so you need to choose the Kedah and Perlis, and then click next, and then click for the geode model, no geode model. Okay, and then click finish. Okay, so settle for the coordinate system. The other one is we need to to set some value in a baseline processing. This one is actually related to the baseline process that you will perform after this, and we will look on the quality. Quality here is actually when you do the processing, there are the acceptance criteria, and you can set by default. However, if your work required to meet certain precision that is not in the default value, so you can change the value here. Okay, so but in our processing, we will just use the default value. Okay, and another one is in the satellites view, you can change the elevation mask by follow the handout. The elevation mask for the processing is in 10 degree, and then you can see here there are several types of the GNSS system: GPS, GLONASS, Galileo, Beidou, QZXS. And in this satellites list, you can tick and untick satellite that you want or you don't want. Okay, you can just untick and tick means you want to include in your processing or not. Okay, and then you can click OK. Okay, and then we will move to the third step, which is to import the data. Okay, there are two ways to import the data. First is by using the import tools here. Another one is you can just drag your data into this plan view. Okay, so I will show you these two ways. First, we will use the import tool here. You just click on the import. Okay, and then browse your file. Here, you can browse your file in the folder. Okay, for example, here, the folder, I already browsed it. And then, for example, not sure this one. Okay, I will choose this one. No. Okay, first observation. Okay. Data, first observation. Okay, there are base CP1 and CP2 here. So I just click here, click OK. And then it will show the list of files that is inside the selected folder. No, okay. I repeat the same process. It is because maybe the data is in another folder, so maybe I can just click on the paste here. Okay. Okay. So there is a okay, the file type unknown here. Okay. So, and then you select the file and then you can click on the import. Oh, this one is in the TPS, TopCon data. So I need to, you must ensure that in order to process the data by using a TBC, the data that can be read by the TBC is the data, observation data by using the Trimble receiver, and another one is by using the RINET file. Okay, so I will add the RINET file here. Okay. It's a folder inside a folder. So I just click OK. Okay. So there is a OG, shift, and then import. Okay, so you can check the point ID and the start time and also the duration. In terms of the point ID, you can rename this point ID. For example, see, okay, let me check. This one base is okay. Wait a minute. Okay, for example, this base one is CRM 36. Okay, you can check the start time and end time and also duration. And then for the antenna, please ensure that this one, because this is the this data is a raw data that is converted from the TopCon observation data. So the manufacturer here you need to check is TopCon, the type is GR5, and then this one for the height you need to recalculate the height so that it will be the bottom of antenna mount. Okay, so you need to recheck or recalculate the height for this data. Okay, and then the receiver here, make sure to check the manufacturer and also the type here. Okay, once you check all the data is available, all the data is correct, and then you can click OK. And now this point has been import to your plan view. Okay, and then we can try to use another method is by dragging the file to the plan view. Okay, for example, here this is the CP1 and this is CRM39. So .to2 means this data is a raw data by using raw data from the observation by using the Trimble receiver. Okay, I just drag into the plan view, and then it will appear the same pop-up window here, the receiver raw data check-in. So this is the let me check on the log sheet, CRM39. CRM39. Okay, and then the start time, the end time, and also duration. For the antenna, I use the Trimble. The type of Trimble is R6, and the height is based on the center of bumper, and the height is 1.4. Make sure to check all of this. Refer to your log sheet so that the height is actually same as the on site. Okay, you can change the value here if the value is not correct. Okay, and then check the receiver, the manufacturer, and also the type here. Okay, and if everything is correct, so you can click the OK button. Okay, so right now, if you look here, this is the 36, CRM36 and CRM39. So I will insert another point since this is the complete network GNSS observation. So I will drag another one which is CRM44. Okay, and then this one is CRM44. It's also use the Trimble here. Click OK, and if everything is correct, you can click OK. Okay, so once you import all the data, you can see there are a point. It is the observation point, and also a line. Line here means it's a baseline. This baseline only appear if the times of observation is overlap. So you must ensure that when you import your data, there is a baseline here, and then so that you can process the baseline. If not, it means you need to do the observation again because without the baseline you cannot do the processing. Okay, the first step is to set the base station. In order to set the base station, you need to click on the point. Okay, and in this data, the base station is CRM36. So you just need to click on the point CRM36 and then right click. Point CRM36, and then after that right click and select add coordinate. Okay, so for the point ID is a CRM36, and then the coordinate type you can select local, and then for the latitude and height you need to set this value based on the base station coordinate. So in this example, CRM36 is the base station that is at the depan taska. So we will change the value to this value. Okay, the value to this value. Okay, so we check the value for the base, that is depan taska, is 6 degree 26 minute and 45, 6 degree 26 minute 45.22403 22403 second. This is for the latitude, and then the longitude is 116.85396 85396, and for the height is 8.718. 8.718. Okay, and then we will change the planar quality of this coordinate to the control quality. Okay, to the control quality, the symbol change to the triangle. Okay, and then can click OK, and you will see that the point before this has changed to the triangle point. This means that this point is selected as a fixed station or as a base station for this processing. Okay, and then the next step is we will perform the baseline processing. Okay, so what you need to do is to select the survey menu bar here, and then click on the process baselines. Okay, so you will need to wait until the processing is complete. Okay, so this process baseline window will appear, and this baseline has been successfully processed. And then there are two items that you need to check after this baseline processing. First is you need to ensure that the solution type is fixed, and then the horizontal precision and vertical precision must be less than 1 centimeter. Okay, so the solution type, there are two solution type, the fixed and also float. Okay, if you get float, it means that the baseline have problem and you need to perform some editing and process the baseline again until you get the fixed solution. Okay, the edit process will be explained after this. Okay, and for the horizontal and vertical precision, as I mentioned before, you need to ensure that the precision is less than 1 centimeter. Okay, and if you look here, this precision is acceptable because it is around millimeter value, which is around the maximum value is 6 millimeter. Okay, and then you can click save. Okay, so once the baseline processing complete, the baseline will change to this color, and then if a red flag appear at any CPs, either CRM44, CRM39 or CRM36, just the 44 and CRM39, so it means that this data is not good and you need to perform some editing. Okay, for example, this data is actually a good data because the precision is less than 1 centimeter and there are no red flag appear in any CPs. However, if the red flag appear or if the precision is more than 1 centimeter and another one is you get the float solution type, so you need to perform some editing. For example, the red flag appear at the CRM 44. Okay, so you need to change or you need to select the baseline that is related to the CRM 44 and CRM 36. Okay, you just need to select the baseline. Okay, select the baseline and then right click and you select session editor. Okay, you just need to click on the session editor here. Okay, so you can see this window. Okay, the G, the R here represent the satellites. The G is a GLONASS satellite, and then R is the GPS satellites, and the C here is the BeiDou satellite, the signal satellite. Okay, the blue line here is the signal from the first point, and then the green line here is the signal data for the second point. And this blank space, if you look here, there are blank space here. So it means this data or there are a missing signal around this blank space. So when you perform an editing, for example, if you got the float solution or the precision is more than 1 centimeter or you get a red flag at the CPs or all of that, so we need to do some editing. There are two editing methods, and this is actually more to the try and error. So it means if this step is not or if this step making the result worse, so you need to undo the process. Okay, so first is the first method of editing is by looking at this signal data, and then we will remove the data that has no signal, which is there for this blank space. We will remove all of this blank space. For example, here we will just drag and select the area that you just need to drag and release. Oops. Remove the time slot. Okay, and then here select. Okay, and if you look here, most of the duration there are missing data. So what we can do is we can just remove all of this signal. So you just click on this and it will inactivate the satellite from the signal from the satellite G16, and then same as G31. Okay, and same as here. Okay, so once you complete this process, so you can just click OK, and then in the selected baseline, you just need to right click and then click on the process baseline for the selected point. So if you see, if the value is not changed, so it's okay. So it means your selected signals that you select to remove is not affecting your baseline processing. If it's getting worse, so you need to remove again that data. So it means you select the wrong data to be removed. Okay. Yes. Okay. And another one is if the precision not change. So there are another method, which is we will use we will check the signal from the satellite one by one. Okay, so what we can do is first go to the report. Okay, wait a minute, I will find the report. Okay, this is the report. Okay, and then select baseline processing report. It will generate the baseline processing report. It will take some time to generate the baseline processing report. Okay, so if you look here, there are 14 pages here. So you can either then we look in this TBC, we can export the file or this report to the PDF. Okay, I just put on the, okay, save. Okay, we can open the report, stop, baseline processing report. Okay, this is the data or the report that only comprise the CRM36 and CRM44. You can select all. If you want to generate, you can select all of this point, all of this baseline if you want to generate the baseline report for all of this data. Okay, so since I just want to check for this baseline CRM44 and CRM36, so I just choose the baseline, and it will show the coordinates. It will show the satellites that only involve that has the signal from the baseline CRM36 and CRM44. Okay, this is the list of the GPS, the satellite. Okay, so now we will check the signals for the baseline involving the satellites one by one. Okay, you can check, this is the residuals for the G1, the satellite G1, which is the data from the GLONASS 1. Okay, and this is actually, this graph is the residual graph. The graph line is based on, this orange graph line is actually based on the recorded signal. For example, if the recorded interval is 5 seconds, so then the dot will appear every 5 seconds, and it will show like this. And also the standard deviation here represent the area value. The smaller the standard deviation, the better the observation. Suppose the data should be this graph is actually represent the residuals. The residuals mean the difference between the average value and the observed value at that time. So the residual should be near to 0. And we will look, in order to remove the widget signal, you need to look on the graph line that is appear large. That is, it's if you look here, for example, this is 0.06, is actually a large residual here. Okay, Okay, and then identify the large residuals and estimate the time of observation around that large residual. For example, here you can see around here the residual is quite large, which is around 0.06, which is around 6 millimeter, and then same as this area. So we will estimate the time here around 10 maybe 10 3 minutes to the maybe until here 10:16. Okay, 10:16 or 10:17. So check to the session editor, and then the G1, even though if you look the G1, it has no missing data, but when you look on the signal here, it's not there are a large residual here, so you can remove the area or the signals around this area. Okay, then I think around 10:3 to 10:16. Okay, 10:3. So you can check the time here around here, 10:3 to 10:16. Okay, around 10:3 to 10:16. Okay, so you can perform one by one. Okay, this one I remove or edges. Okay, divide. Okay, and then you can check one by one the signal. This is the standard deviation for the G3 here. Is around 2 centimeter. This one is good. You can see the signals, the residuals is small here, around here, and then this one is G7. It's not good. It has a large residual around here, so we can remove all of this G7. So you just select around here. Okay, and then check one by one until finish. Okay, for example here G16, there are not enough data here, not enough signal G16, so you can remove. Okay, and then once you complete analyze all of this signal, you can click OK and then perform another process. So if you look here, it's still not changed the value, the precision value is not changed. It's okay because this one is actually within the tolerance, which is less than 1 centimeter. However, if your data, the processing results, the precision or the solution is fluid and precision is more than 1 centimeter, you need to check the signal one by one. And then you can perform the baseline, either single baseline, or you can just select all and process the and do the and click on the process baseline again. Okay, once it's done, once this process done, you need to remember that this process is actually a try and error process, and then you can go through each satellite, then perform the baseline processing again, and if the value is not is getting worse, so it means you select the wrong data to be removed. Okay, and then so you need to remove it again. Okay, and after that, if all the data is okay, the solution type is fixed, and the precision is less than 1 centimeter, we can perform. Okay, we can do the network adjustment. So you just click on the adjust network here. Okay, I'm sorry. Select the line and click on the adjust network. and this adjust network box will appear. Okay, and in this adjust network box, select the constraint. Okay, click on the constraint. There are constraint and weighting. Click on the constraints, and then it state here this is the fixed coordinate by using CRM36. Okay, and the type is local. Check the 2D and height. 2D means the horizontal value, latitude and longitude, and H is for height. You cannot click on the E. It is because you select the local coordinate on the starting process. Okay, and then you can click on adjust button. Okay, and you can see here the chi-square test is failed. It should be pass. If you get fail, click on the weighting and then click on this multiply symbol. Okay, just click on this and it will change the value here, and then you go to constraint again and click on adjust. Okay, and it will change to pass. This process only be done if the chi-square test is failed. If you get a pass here, no need to do this process. Okay, alright, so click OK, and the chi-square test here pass, and then you can click OK, and lastly you can go to report and generate a report for the network adjustment. Just select the network adjustment report, and it will show you the network adjustment report, the adjustment setting here, and the control points constraint, which is the CRM36. That is the point that we set as the fixed point or the base point. And this adjusted grid coordinates is the final coordinates. So the CRM44, the final coordinate for the CRM44 and CRM39. The LLH here means it is a fixed station. Okay, and then there are adjusted geodetic coordinates here. I'm sorry, not the adjusted grid coordinate. The adjusted geodetic coordinates is the final coordinates, and it's same as I said before this. LLH means it is the fixed station. So CRM36 is the fixed station or the base station. So the final coordinate that you obtain from this network adjustment is the CRM44 and CRM39. Okay, and adjusted GNSS observation here shows the precision and residuals of the observation. Okay, so I think that's all for the processing. Thank you.